Today's lesson is decimals in the divisor. It's lesson 5.7. The color that we're using is a red violet. It's like a fuchsia color. Please make sure that the date gets put in the date box and that you have the whole title set up before you resume the video. Okay, there are a lot of journal pages that we're getting through today, so we are going to go pretty quickly through this. I need you on task. I need you writing everything as quickly as possible. Alrighty? Step number 1, when we're dealing with decimals in the divisor, remember that's the number that's off to the left. Step number 1 is to locate the decimal. So you're going to have to look for it. So I'm going to draw some eyes. Looking over to the left. Step number 1 is to look for the decimal. Step number 2, your whole goal on step number 2 is to get rid of it. Put that in quotation marks. What get rid of it means is that I want to move it. I want to kind of take it out of the picture so that I can do normal division and then place my decimal back in, kind of like what we did with multiplication. We use a decimal box to move the decimal out of there, and then we put it back into our answer. That is what the idea is here. So when we get rid of it, well, here is what is actually happening. You're going to multiply the divisor by a power of 10. Multiply the divisor by a power of 10 to get rid of the decimal and make the divisor be a whole number. So again, multiply the divisor by a power of 10 to get rid of the decimal and make the divisor be a whole number. The next bullet point under there is, remember, multiplying a number by a power of 10 is simple. Let's underline simple. Remember, multiplying a number by a power of 10 is simple, period. It just means you move the decimal to the right. And how many times do you move that? Well, it depends on the power of 10, the exponent, right? Multiplying a number by a power of 10 is simple. It just means that you move the decimal to the right. Then we're just going to put the exponent tells you how many spaces to move. So if the number, let's put that in the color. If the number is, if you're trying to move it 3 times, then what you did was you multiplied by a power of 10, but it was 10 to the third. So here's an example. 10 to the third would mean you move the decimal 3 times because of that exponent. And which direction do you move it? to the right. I'm going to draw that arrow, this red-violet color. That little baby 3 is why you move it 3 times to the right. Okay, that is a lot of writing, I know. But let's just practice a couple of those before I move on to step number 3. Okay, let's say the number is 1.364. And I want to make that a whole number. What would I multiply that by to make it a whole number? It would have to be a power of 10. And let's see how many times I would need to move it. I'm going to pick up the pink or the red-violet and scoop over until it becomes a whole number. If I only move it one place, it is not a whole number yet. So it can't be 10 to the first power. If I move it 2 places, it still isn't a whole number, but that would be 10 to the second power. What if I move it 3 places? And the decimal is there at the end of that number. Would that be a whole number? Yeah, it would be 1, 3, 6, 4, and the decimal would be at the end, so I would have a comma. So in order to get that number, 1.364, to be a whole number and no pieces, I had to multiply it by 10 to the third power. So put a little 3 above that 10 because I moved it 3 times. That was 10 to the third. Okay, let's try another one. What if I'm moving 4.8 and I want that to be a whole number? You're going to have to multiply it by a power of 10, and let's just see how many times I'd have to move it. If I moved it 1 time to the right, would there be a whole number without any pieces? Yeah. So to get it moved 1 time to the right, it would become 48, but it means that I only had to multiply it by 10 to the first power, or 10 to the 1 exponent, because I moved it 1 time. Does that make sense? That's just some practice examples of what we mean by these 2 bullet points on number 2. Okay, what's interesting is when we move on here to step number 3, is you're going to multiply the dividend by the same power of 10 that you did to the divisor. Multiply the dividend by the same power of 10 that you did to the divisor. So I think what helps me remember this is, you know the phrase we used to use with fractions? Let's put this in a cloud. It was the phrase, whatever you do to the numerator, you have to do to the denominator, or vice versa, right? I'm going to make this cloud be the red-violet. This time, we're using it with division, so we're going to say, whatever you do to the divisor, you have to do to the dividend. So if I'm going to move the decimal in the divisor, it means I have to do the same thing in the dividend. You can't just change something and not change the other part of it. So whatever you do to the divisor, let's put that in quotes, comma, you must do to the dividend. Whatever you do to the divisor, you must do to the dividend. That is step number 3. What's interesting about step number 3 is you might have to add zeros to the end of the dividend. Like it might already be a situation where the decimal is at the end, or you can't move it anymore. So that might come up, so I'm just going to put a little bullet point right here. You might have to add zeros to the end of the dividend. you might have to add zeros to the end of the dividend. Again, we're going to practice this. Okay, we're going to practice a lot of this. We're just writing all of the steps right now. Let's move on. Step number 4. If there is still a decimal in the dividend after you've moved it, you just move it straight up into the quotient. And we've done that before, where we have the decimal in the dividend and we moved it straight up into the quotient. So after you move the divisor's decimal and then the dividend's decimal, if there is still a decimal, so let's write that, and that's only an if, it doesn't always happen. If there is still a decimal in the dividend, after step 4. Sorry, after step 3, it's not step 4. If there is still a decimal in the dividend after step 3, so if that happens, then, remember if comes with statements like then, so if, then. If there is still a decimal in the dividend after step 3, then move it straight up into the quotient. Okay, we know how to do that. You only have to do step 4 if there is still a decimal in the dividend after you've done step 3. If there's not, you can skip straight to step 5. And step 5, my favorite step, because it's my favorite number, is just solve the division problem. So you have to know how to do division if you want to get this far, right? You can't be doing this complicated division if you don't understand the basic division that we've been practicing. So all we're doing here is adding more decimals to deal with, which you can totally do. Now that we've written all 5 steps, let's turn our journal page and let's just practice several, okay? Let's just practice several. Oh, something that I want to say on this one, on step 4, if there's a decimal in the dividend after step 3, then move it straight up into the quotient. On step number 5, solve the division problem. Sorry, go back before you turn your journal. I want to put in a box right here. Rewriting the problem might be helpful. And you'll see why in just a minute. Rewriting the problem might be helpful. That's like a hint, you should probably do this. I'm not going to make you do it every time, but on a test, I think that would be really critical and for you to understand it. So rewriting the problem might be helpful. Just because we've got a lot of decimal movement happening, we might be adding zeros, we might be moving the decimal up, so it can get really complicated. And I just want to make sure that we are being very clear and rewriting it if we need to. Okay, turn your journal page and let's practice one. Okay? The first thing we're going to do is 63 divided by, let's just do long division, 0.9. 63 divided by 0.9. Will you take the color, the red violet, and make the division house like that? I know it takes a little minute to adjust to the light. Okay, 63 divided by 0.9. So our first step is to look for the decimal. I see it. It's in the divisor. The second step is to get rid of it. To get rid of it, I need to times it by a power of 10. What power of 10 would I times 0.9 by to get it to be a whole number? Like, how many times do I need to move that decimal to the right? 1 time. So I need to times this right here, that divisor, by 10 to the first power. I have to multiply that by 10 to the first power. And if I'm going to multiply the divisor by 10 to the first power, I also have to multiply the dividend by 10 to the first power. So let's come on back and let's just take a look at this. So I'm going to multiply it by 10 to the first power, which means I'm going to get rid of it, right? I'm going to multiply this, and it's going to move the decimal over. It's going to move the decimal over. What did my new divisor just become? 9. So I'm rewriting it. This is so important. I'm so sorry I did not make you write that out on the steps previous to this, but I think it's going to be so important to rewrite the problem, because look how messy it is already, and I haven't even gotten to the dividend. All I've done right here is step number 2 to get rid of it. Now I'm on step number 3. Multiply the dividend by the same power of 10 that you did to the divisor. So if I times this by 10 to the first, I have to times 63 by 10 to the first. Well, there's no decimal in 63, so where is it at right now? It's at the end. So I have to add zeros in order to move it, or basically if I just say, well, what is 10 to the first? It's 10. If I take 63 and I move that decimal, which would be here, go ahead and place it, it would be here. If I move it one time, then the number doesn't become 63, color in this lovely 0, it becomes 630. So I rewrite it over here, and I solve, well, sorry, that was step number 3. Step 4, if there is still a decimal in the dividend, then, well, there's not a decimal in the dividend, because I just got to add a 0 to it because I just moved it once. So I'm golden. I don't have to do step 4. Step 5 is just to do normal division. So think about this really quickly. Will 9 go into 6? No. So you should place an X there, a baby X. Will 9 go into 63? Yes, exactly 7 times. When I subtract, I bring down. Will 9 go into 0? No. You have to put the 0 up here if you say no. And 9 times 0 is 0, and 0 minus 0 is just going to be 0. So I have my final answer, and it is 70. Here's what this really means. This means if I do 70 times my original number, 0.9. 70 times 0.9, I would get 63. So the original means 70 times 0.9 should give me 63. Let's solve that multiplication problem just to see if it really did work. You ready? Decimal box. There's a 0 at the end. It's our friend. There's a 0 out in front. It's a runt. So I took care of this one. Brought it down here. Squash that one out. And then 9 times 7 is 63. But I have a decimal box of 1. So I bring it over and I move it once. And I got 63. So I took my original divisor and multiplied it by my new quotient, and I got my original dividend. So that's what the original means, is you kind of have to go back to that. And that can be a little confusing, but let's just keep practicing. You're going to understand it more and more as you practice, okay? Let's try another one. Let's try 72 divided by 0.08. 72 divided by 0.08. Okay, in order to move this decimal, the two places I need to move it, if I move that decimal 2 times, it was like multiplying by 10 to the second. See how that's pretty clever? So if I multiply this number by 10 to the second, 0.08, I get to move the decimal twice. And what is my new number? It's not 0.08. If I multiply that by 10 to the second power, it just becomes 8 as my divisor. Well, if I multiply the divisor by something, I have to multiply the dividend by something. So how do you multiply 72 by 10 to the second? You still have to move that decimal 2 times. The decimal's at the end here. So I fill in the zeros. And if this is confusing, just think to yourself, okay, well, I have a 72, and I'm going to be multiplying it by 100, because 10 to the second is 100. So 72 times 100 is 7,200. So this is kind of how I do the work for this, so that I can solve the problem. Okay, 8 doesn't go into 7, but it will go into 72 9 times. So 8 times 9 is 72. Subtract, you get zeros. Hopefully you're catching on to this pattern. Will 8 go into 0? No. So you bring down the next number. Will 8 go into the other 0? No. So I get 900 as my answer. That means that 900 times 0.08 is 72. Pretty interesting. Shall we keep trying? Let's do another one right here. I actually really like to see the sets of them working together. So here's an example of the rewriting and how important that is as you get going. This other problem, all of this went with the other problem, right? Can you see that? This whole thing went together. Pretty crazy. All right, let's try another problem right here to the right of this problem. This is going to be, let's do 0. Well, let's make it a little harder, shall we? Okay. No, actually, sorry. I don't know that we're ready for that yet. So let's just try it again. Let's try 42 divided by, wow, 0.007, or that's 7 thousandths. Well, to get rid of this decimal, you're going to move it 3 times, which meant 10 to the third. So I just created the divisor as being 7, right? And now whatever I do to the divisor, I have to do to the dividend. So if I move this 3 times, I need to move this decimal 3 times. Here it is at the end. Or if that's confusing and you're like, I don't know where the decimal is, just think, well, what's 42 times 10 to the third? Or 10 to the third is 1,000. So it would be a 42 with 3 zeros. And this is actually mental math division, because I know that 7 goes into 42 6 times, which is 42. And then I know these are all going to drop down to zeros. So these will all fill in with zeros. We'll practice that a little bit more when you get called up to groups with Ms. Fisher, but that's kind of how that works, is it actually becomes mental math if they're in a fact family. Like 7 and 42 was in a fact family, right? 7 times something gave us 42. So 7 times something will give us 42,000. That's how that works. Okay, separate that out. And we're going to try a slightly more difficult problem. You ready? It's 372 divided by 0.4. 372 divided by 0.4. Okay, let's go for the first step. Locate the decimal. Point to it in 3, 2, 1. Move it to get that 0.4 to be a whole number. You moved it one time, so that was multiplying by 10 to the first power. It changes it to a 4. If I multiplied the divisor by 10 to the first, I have to multiply the dividend by 10 to the first. And since there's not a decimal here, I just add 1 0 to the end of it. So this number became 3720. And now there's no decimal in the dividend, so I don't need to move it up. I just get to do normal division. I'm already on step 5. Will 5 go into 3? Sorry, I'm on step 5, but I'm dealing with 4 as the divisor. Let me rethink this. Will 4 go into 3? No. So you place an X there. Will 4 go into 37? Yeah, 9 times. And that's 36, so you subtract 36. You're doing normal division now. Bring down the next number and start over. Will 4 go into 12? Yes. 3 times. You have to bring down that last number, even if it's a 0. And will 4 go into 0? No. I know it's just going to be 0 if I keep subtracting. So my answer is 930. How are you doing? Doing okay? Thumbs up if you're doing okay. I think you can do this. I know you can do it. It's just understanding that when I multiply by a power of 10 to get rid of the decimal, I have to multiply by a power of 10 there as well. Otherwise, I'm going to get a different answer that might not be correct. Okay, and I don't really want to deal with that. So the next video, we are going to work on some story problems. But what I want to do now is actually keep practicing a couple more here. So get ready for this. You can do it. Just be thinking of all the different things that come up when you're doing this new division with, decimals in the divisor. Okay, let's try another one. Let's try 884. I'm going to just come down here to the left. 884 divided by 0.26. So now we're throwing in some other skills. We're throwing in our double-digit divisor skills as well. But let us focus on just the decimals for a moment. I have a decimal in the divisor, so I need to get rid of it. I've got to make this 0.26 a whole number without any pieces. So I'm going to move it twice, which is timesing by 10 to the second power. It changed it, so rewrite it to 26 as the divisor. When I multiplied this by 10 to the second power, I also have to multiply the dividend by 10 to the second power. Since there is no decimal here, I just add 2 zeros to the dividend. So it would be 884. Then I've got those 2 zeros. Where is the decimal at right now? It's at the end of this second 0. And if I needed to, I would move it straight up. But right now, I don't think we'll need to. So let's just try it. And if we do need to, that's okay. We can when we get there. So 26. Oh, yeah. This is not going to be mental math. This is going to be me rounding to have it be mental math. 26, I know some of you might say 30, it's close to 30. But really it's closer to 25. And when we do double digits, we're just picking a number that makes this easier for ourselves. So I'm going to do 25 because I can count by quarters or with money. So I'm going to use 25 because that's closer than 30. 25 or 26 won't go into 8, but it will go into 88. So that's where I have to start. And I just think of quarters. I'm trying to get to 88. 25, 50, 75, 100. It's not going to be 4 times. It's probably going to be 3 times. So I'm going to try the workout right here. Go back to your original number. Try 3. Did you get 78? So put a 3 in your quotient line, subtract 78, and you'll get 10 left over, and you bring down the 4. Well, if multiplying 26 by 3 was 78, could I get 26 more? Like, will it be 26 times 4? Maybe, because 20 more would be 98, and I get to do 6 more. Yeah, let's try 4. Let's do 26 times 4. I can use all of this space for my work, and I'm not going to erase any of my division or multiplication because it's going to help me later. 4 times 8. Look at that. It was exactly 104. So if 4 goes in the quotient line and you subtract the 104, and you get 0, and then you look and say, oh, I got to bring down the next number. Even though it's a 0, bring it down. Will 26 go into 0? No. You would bring down the other one, and no. So my answer is 3,400. Pretty cool how we can use our powers of 10 to make this so much easier. I also circled the answer, 930. All right, we are going to be practicing some story problems in the next video, so gear up and let's just draw a big arrow down here at the bottom that kind of just shows that we're going to move on to some story problems. You will not need your workbook. We are going to actually be writing them. I know you're loving this, all this writing. Okay, see you in the next video.